Hello there. You're watching the full video tutorial on creating breeding trial experiments. You can also watch each step separately in our 6-part series, so you can skip to more relevant ones based on your needs. Our first task is to navigate the Experiment Creation tool. On the left navigation panel, click Experiment Creation. This is the Experiment Creation data browser, where you can see a list of all experiments created, some basic information about them, and their statuses. The blank spaces below the column headers act as filters, while some columns can also be sorted. At the leftmost column of the data browser, we can see a set of icons that we can use to view, update, copy, or permanently delete an experiment. These icons are available depending on the status of an experiment and your profile's roles and permissions. If you need additional access, contact your data manager or send us a support ticket via the help button on the menu bar. Moving to the rightmost part of the screen, we can see the toolbar just above the data browser. The Personalized Grid Configuration button lets us adjust the view of the data browser to our liking. The Reset button removes any filters applied, while the bell icon houses notifications. Now that we're familiar with the browser and its tools, let's go ahead and create our breeding trial experiment. To begin designing the experiments, let's click Create. We are redirected to the Create Experiment page to specify the kind of experiment we want to make. On the Experiment Type drop-down, let's choose Breeding Trial. The page is then updated with the steps required to create our chosen experiment type. The first step is to provide basic information for our experiment. All fields marked with an asterisk should be filled out, but we are highly encouraged to provide as much information as possible so that our experiment will be easy to identify later on. To begin, we can nominate an experiment name or have it auto-generated. The data fields for stage, evaluation season, pipeline, objective, and project should be filled out depending on the purpose of the breeding trial, while experiment year and steward are pre-selected. We can still change the assigned steward if we are creating the experiment in behalf of someone in our team. After filling this out, we can now save the basic details of our experiment. Once done, we can now go ahead and add entries to our experiment. After the Basic tab comes the Entry List tab, where we can add entries to our experiment. We can do this by clicking the plus button on the toolbar. The modal window presents us with 4 ways to add entries. First is the Input List, which lets us add germplasm names, package labels, or package codes. The Copy Entry List lets us copy the entries of another experiment, while the Advanced Nursery allows us to select seed sources from another nursery experiment, with seed packages in the inventory. A breeding trial experiment mostly uses the Saved List option. Here, we can add entries from a list that we previously saved in the system. Clicking on the Select Saved List icon automatically adds the entries to our browser. Then, we need to check if the seed source of our entries are owned by our program. This information can be seen on the rightmost column of the data browser under Availability. Of course, we can only use entries whose seed and package records are owned by our program. The entries must have an availability status of Selected, which means that the system already selected the only existing package record for that entry. If there are multiple package records available for an entry, a status of Select will be displayed and will require you to choose from the available package records one entry at a time. The same can be done in bulk using the Settings button on the toolbar and selecting the packages for all or some selected entries. We are then asked to supply some details so that the system can filter the package sources for us. Lastly, an unavailable status means that the seed sources belong to another program, so we need to remove them in our entry list. To do this, simply select the unavailable entries. Click Settings on the toolbar and choose to remove all or only those selected. For breeding trial experiments, we are also required to identify which entries will be used as checks and tests. Under the Entry Type column, we can see that entries are assigned as tests by default. We can reassign some of these to be used as checks by clicking on the drop-down menu. Check entries can also be further classified as either spatial check, performance check, repeated check, or local check using the drop-down menus under the Entry Role column. Unlike the Entry Type column, Entry Role is not required. We can also do this step in chunks using the Bulk Update button by selecting the variable we want to use, providing the necessary information, and then applying it to all or selected entries. Our entries can also be rearranged using the Manage Sorts button. The modal window allows us to specify our preferred order by column and apply it to our entry list. The option to save the specified order for later use is also available. We can also export an offline copy of our entry list using the Download button. After managing our entries, we can now proceed to the Design tab. This one explores creating non-sparse designs. As soon as our entry list is finalized, we can now select our experiment design. On the far right portion of the screen, let's toggle to the old interface. This option is recommended because some features are yet to be available in the new interface. In EBS, there are two testing methods used to allocate our entries: sparse and non-sparse. Both of these can be used with all EBS-supported designs. By default, the Design tab is set to non-sparse testing as indicated by None under the Across Environment Design data field. Let's use this one. Next, let's select our preferred design. To proceed with the design, we have the option to randomize in EBS via the Generate Design button or upload a design file that matches our selected design. For the latter, a template can be downloaded from the modal window, as well as a reference file containing information on the required headers for each design. Browse and upload the design file and wait for it to be validated successfully. On the other hand, we can use the interface to randomize in EBS. Simply fill out the required specifications and proceed to generate the design. We can then view the planting arrangement using the entry number, plot number, plot code, and block number. A toggle to switch the first plot position from the default top left to the bottom left can also be used. Alright, that's it for non-sparse testing. Let's now explore another testing method called sparse testing. We are still on the Design tab. On the far right portion of the screen, let's toggle to the new interface. Take note that when using the Design tab's new interface, you will not be able to perform usual actions such as creating a copy of the experiment, regenerating its design, or adding more occurrences, as these features are still under development. Alright, moving on, there are two testing methods used to allocate our entries in EBS, namely sparse and non-sparse. By default, the Design tab is set to non-sparse testing as indicated by None under the Across Environment Design data field. Let's switch to random so we can use sparse testing, which allows entries to be randomly distributed to different occurrences. The interface loads a new page where we can choose between generating the randomization in EBS or uploading a design file. To do the latter, toggle to Upload and click the Upload button. A template can be downloaded from the modal window, as well as a reference file containing information on the required headers for each design. Let's upload our file and pre-validate. The summary information will then be displayed, which also requires us to select the design for each parameter set. Parameter sets are groups of occurrences with specific protocols, which include the trial design to be used. validate the design file, and confirm. As soon as the file status is set to uploaded, we can view the design using the eye icon. If any revisions are needed, we can still delete these and re-upload new files. Let's now try generating the randomization in EBS. First off, we need to specify the number of experiment occurrences, including the number of iterations. Remember that the number of experiment occurrences should be equal to the total number of occurrences created in all of the parameter sets. Otherwise, we cannot submit it for randomization. Next, let's click Assign to load a page, where we can specify the total number of replicates per entry of the experiment, or total nreps for short. This defines the number of seed packets that will be used to plant each entry. So this should account for all the entries and their replicates multiplied by the number of occurrences specified in all of the parameter sets. Simply put, the total nreps should reflect the total number of seed packets needed when planting the experiment occurrences. Let's make sense of that with this example. Here, we want to create two parameter sets with these details. Let's look at our check entries first. Parameter set 1 has 2 occurrences, with each one requiring 3 checks that will be replicated twice. On the other hand, parameter set 2 has 3 occurrences, with each one requiring 3 checks that need to be replicated twice. That means the total nreps for each check entry should be as follows. This successfully accounts for all the check entries' replicates, multiplied by the number of occurrences specified in all of the parameter sets. Let's reflect the total nreps here, either one at a time or in bulk. Let's now move to our test entries. Parameter set 1 requires 25 test entries with a replication value of 1.4. This value means that the test entries need 1 seed packet for planting, and 40% of it need to be planted twice. So that's 10 tests replicated twice, while the rest of the 15 tests need only 1 seed packet. But because parameter set 1 has 2 occurrences, we multiply the nrep values by 2. In summary, we have these total nrep values for test entries in parameter set 1. Let's do the same for parameter set 2. This requires 35 test entries with a replication value of 2.2. This means that test entries need 2 seed packets for planting, while 20% of it need 1 more. So that's 7 tests replicated thrice, while the rest of the 28 entries need 2 seed packets. But because parameter set 2 has 3 occurrences, we multiply the nrep values by 3. In summary, we have these total nrep values for test entries in parameter set 2. Adding these to parameter set 1, we have these total nrep values for our test entries. Let's go ahead and supply these details in EBS. Let's click the back arrow button to continue working on our parameter sets. At this point, we can select the occurrence design. Unlike the upload option, randomization generated in EBS for sparse testing only supports the partially replicated design as of now. Additional fields are loaded that enable us to specify the design. Simply populate the rest of the fields for each parameter set based on the specifications we had earlier. As of now, the method of replicating test and check entries is limited to random. This means that EBS randomly allocates the entries in each parameter set. Lastly, the maximum number of plots should be equal to or greater than the sum of plots needed to plant check and test entries and their replicates. This value must reflect at least the minimum number of plots needed to plant each occurrence in a parameter set. For parameter set 1, we just need 41 plots. Let's save these to create parameter set 1 and move on to create the next. Again, take note that the number of experiment occurrences should be equal to the total number of occurrences created in all of the parameter sets. Otherwise, we cannot submit it for randomization. Let's create parameter set 2 using the same steps. For this one, we want to define the shape or dimension of the design. Finally, let's submit the parameter sets for randomization. Wait until the status of the request is set to randomized. Only those parameter sets whose field layouts were defined earlier will have the view icon enabled. In case we need to revise a successfully randomized parameter set, we can still do so by deleting the generated plot records. On the other hand, if randomization fails, we can view the error message to guide us in correcting it. Simply edit the parameter set or delete it to start again. That's it for sparse testing. Let's now move to the Protocol tab. Let's define the protocols that will be used to manage our plots throughout the season. There are 5 protocols that we can fill out, depending on the objectives of our experiment. Remember that this step is optional at this stage, and we can still specify our protocols after the experiment creation is done. For our breeding trial experiment, we need to specify 4 of the 5 protocols, with the trait protocol being the most important. Here, we select the traits we want to observe in our experiment. One way is to add them individually using the Traits subtab. Let's select a trait from the drop-down menu, and then click Add. The selected trait will be displayed on the right browser. We can add more using the same steps. We can specify any instructions we have when collecting data for each trait. The toolbar also houses other tools that can be used to manage the added traits, such as delete and replace. Another option is to use the Trait List subtab if we have an existing trait list we can use. Next is the planting protocol. This is also an important protocol because planting sites will differ in their field sizes. Here we can set the crop establishment, planting type, and plot type. Then let's fill in the remaining blank fields, including the planting instructions if we can. After that, let's click Save. Third is the management protocol. This is where we specify how we will manage our experiments in the field. For example, we can choose which fertilizers to apply, what water management to employ, and other processes that have to be noted for the experiment. One way is to add them individually using the Management Variables subtab. Let's select a management attribute from the drop-down menu, and then click Add. The selected variable will be displayed on the right browser. We can add more using the same steps. We can specify any instructions we have for each management variable. Another way is to create a management variable list by selecting the added variables and saving it as a new management variable list. This is most helpful when several experiments require the same set of management protocols. Once we have a saved list, we can just go to the Management Variable List subtab and select our list. Lastly, we have the Harvest protocol, where we can specify the harvest method and instructions for our plots. Let's choose a harvest method from the drop-down menu. We are also encouraged to specify the harvest instructions. After these, let's click Save. That completes our protocols. Let's now proceed to the Site tab. It's now time to specify the site where our plots will be planted. To do that, we must first manage our occurrences. An occurrence is an instance of the experiment associated to a specific site that includes some or all of the entries included in the original experiment entry list. Breeding trial experiments will usually have more than one occurrence to test the same set of entries in multiple environments and stress conditions. Here, the system automatically created the occurrences for our experiment, as specified during Step 3, Design. The occurrence name is also provided, but we can still modify this to something more meaningful. Let's keep in mind that we can add occurrences even after the breeding trial is finalized and created. Next, we need to identify the site for each occurrence. We can do this one at a time or in bulk. We can also use the Site List button on the toolbar. Take note that site lists are prearranged with data managers. The field, description, and contact person data fields are not required, but we are encouraged to fill them out. Let's save these details to move to the Review tab. Our last step is to review and finalize the details of our breeding trial experiment. The data browser is divided into two sections. The top section shows us our entry list, while occurrences are displayed at the bottom section. We can see more details of the occurrence by clicking the expand icon. If the Complete Creation button is disabled, it means that we have one or more entries whose package sources are not yet selected or unavailable. Simply go back to the Entry List tab to update this. If no other changes are needed, we can go ahead and complete the creation of our experiment. The page refreshes to the Experiment Creation Data Browser, where we can now see our experiment listed in the system, with the status created. That's the last step in creating breeding trial experiments in EBS. You can now move to the Experiment Manager tool or explore other experiment types.